Quantum theory describes the behavior of light and matter on an atomic scale. We usually think of light as a wave and electrons as particles. Electrons within a TV set can be described as particles. In other situations, electrons are better described as waves. Suppose we do an experiment using marbles to represent particles. They roll through open door A and are counted. The graph shows the greatest concentration of marbles near door A. A similar graph is produced when the marbles roll through door B. If both doors are open, we might expect the graph to look like the sum of the two previous graphs. Let's do the experiment. The results match our prediction. To compare particle and wave behavior, we replace the marbles with water and the counters with detectors for wave intensity. With a single door open, the results for waves look the same as for particles. What happens when both doors are open? We get an entirely different graph. The waves passing through the two doors interfere with each other, heightening the wave in some places and canceling it in others. A maximum occurs along the midline between the two doors. Imagine that we do this experiment with electrons. A hot wire emits electrons, and they are counted by detectors at the far end of the apparatus. We adjust the source of electrons so that on average there is only one electron in the apparatus at any given time. When only one door is open, results are similar to both particles and waves. What kind of graph would you expect to see when both doors are open? Remember, only one electron is traveling from source to detector at any one time. If you predicted that the graph would look like the graph for particles, you would be in good company. Most scientists would have said the same thing prior to the advent of quantum theory. In actuality, the electrons do interfere with each other, behaving like waves. But how can the electrons interfere with one another when they pass through the apparatus one at a time? This is the question that makes quantum theory non-intuitive. It may not seem possible, but this is the way nature works.